Okay, so 5, 6, inverse relations and functions. So we're going to be doing that for the next 2 days. We have our review on Thursday and our test on Friday. Okay, so what is an inverse of a relationship represented in a table? So inverses interchange range and domain. So X is domain, correct? And range is Y. Just a second, I have to sync a pin. So I need to switch my domain and range. So you physically just interchange them. So this is F. And so F inverse, and we put F to -1 of X. That's inverse. What would the new X's be? No, just switch them. 1, 4, 3, 1. And what would the Y's be?
-2, -1, 0, 1.
See that? That is what an inverse does. Okay, so if this is, we're going to name this G of X.
Does that not have a pattern?
No, just this is just a, this isn't written from a. Okay, so G inverse of X. So what are my X's?
-1, 0, 1, 2, 3, 4.
Nope.
No,
9.
5, 3, 1, -1.
And so my new Y's are
-1, 0, 1, 2, 3, 4.
inverses physically switch domain and range. That's what they do. They pick them up and switch places. Make sense? Okay, so they are going to give you a table and say, show me F inverse, or show me the inverse function, or what is the inverse of the relation. I guess they didn't say they were functions. I did. Probably shouldn't have done that, but oh well. To find the inverse relation of an equation, you interchange. This is something you will need to do. You interchange the X and the Y and solve for Y. That's all you do. So it says interchange X and Y and solve for Y. So F of X really is just a Y, isn't it? Not just a Y. So I have Y equals X squared, so I interchange those two. So X equals Y squared. And then it says solve for Y. So how would I solve this for Y? What do I have to do to get just Y?
Square root it.
Take the square root. And since I'm taking an even root, I have to make it Y equals plus or minus the square root of X. So this is F, and this is F inverse. So we would just write it F inverse of X equals plus or minus the square root of X. Make sense? So how do you find an inverse relation of an equation? Change X into Y, Y into X, and solve for Y. You guys good? Ainsley?
Yeah.
Okay, so find the inverse. So what's it say to do? But I do it how?
Interchange X.
And Y. So then it becomes X equals 2Y plus 1. And then what? Okay. So how do I solve that for y?
Minus 1.
-1. And then divide by 2. So f inverse, if we want to write it in slope-intercept form, would be 1/2 x minus 1/2, correct? And I could graph that.
Whoa, what did you just do?
I divided everything by what? 2? Isn't there a 1 right here?
Half of x is the same of x divided by 2.
Yes. So this is the same as writing that. So this way, when I look at it, I have my y-intercept, correct? And my what?
X-intercept.
No. Your slope. You guys should know that one. Slope-intercept form. I gotta see something. Okay. Okay, remember if for a function, inverse is also, for an inverse also to be a function, it needs to be 1 to 1. Okay, that's something we talked about early in the year. And 1 to 1 means for every x, there is only one y, and for every y, there is only one x. So if I have a picture, right here, I got a picture, right? If it's a function, what test does it pass? Do you guys remember? I had the vertical line, right? Any vertical line I draw, here, 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 any one I draw, how many times does it hit this graph? Only what? Once. So if it's a function, it's only going to cross it once, correct? If it's not a function, then it doesn't. So if it passes that, we're saying every every x has one y. Now, that's the one part of it. That was the vertical line test. Now, guess what the other one is? Anybody?
Y has 1x.
Every y has one x, so what kind of line would that be?
Vertical.
A
Horizontal.
horizontal. So, when I draw a horizontal line, what happens?
What is it? Twice.
It only hits it once down here on the x-axis, but everywhere else it's hitting it twice, right? So is this a 1 to 1 function? No. Because every y doesn't have one x. We can't go backwards because it didn't pass the horizontal line test. Does that make sense? So 1 to 1 means every x has one y and every y has one x. It would pass both the vertical and the horizontal right here. That's the next statement right here. Now I'm going to erase all this stuff over here because I have a bunch of it. So this is a function, correct? Passes the horizontal line test. It passes the vertical line test. It doesn't pass the horizontal line test. But could I restrict the domain so it would pass the horizontal line test? Could I take part of it? Because right now my domain is all real numbers, isn't it? I can put anything I want in there. This is the equation for f of x equals x squared. I can put anything I want in there, correct? What would happen, what could I do to make it, like could I restrict it from -2 or -3 to 3? I could. Is it 1 to 1? Is it 1 to 1, guys?
Yeah.
No. It still doesn't pass the what?
The
Horizontal line test. So give me something that I could restrict it that would pass both the vertical and the horizontal.
Plus 4.
Huh?
Actually, minus.
I got to get a range because right now it's negative infinity to positive infinity. Correct?
One line goes down.
I tried negative 3 to 3, and that didn't work, did it?
0, 0,
What?
0, 0.
0 to what? I gotta have a start and an end point in my domain on the x-axis. Give me something. Try something. Throw something out there, guys.
0.
0 to what? You have to have a
0.
start and an end.
0 to 0.
0 to 9. So if I go to 0 to 9, inclusive, so that means I have nothing over here. This is gone. All this is gone. And 0 to 9, I'm assuming this is just going to keep going up, right? Does it pass the vertical line test from 0 to the right?
Yes.
From here on, it passes the vertical line test, yes?
No. Yes.
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 Okay. Does it pass the horizontal line test?
Yes.
Yes.
God, I'm a genius.
Okay. So if I restricted this domain instead of from the original function was negative infinity to positive infinity, it wasn't 1 to 1, was it? Was it? Guys, what is 1 to 1? You're looking at me like I'm talking French.
Anything greater than 0.
What is 1 to 1? What is 1 to
X only
1?
has one y and y only has one x.
So that passes the what and the what line test.
Vertical and horizontal.
Okay, so this is the original function. Does it pass the vertical line test? Does it pass the horizontal line test?
No.
No, because it hits it how many times?
Twice.
Twice. It could hit it 28 times and it still fell it, right? Now, Bladen said, let's get rid of this. This is gone. Because he's saying it's no longer from negative infinity to positive infinity. It's only from 0 to 9. Or could I put 0 to infinity?
No.
Okay. If I restrict my domain from inclusive 0 to infinity, is it going to pass both the vertical and horizontal line test?
Yes. Could you also do like negative infinity to 0?
Yes. You could restrict it from 0 to positive infinity, or you could say negative infinity to 0.
What are the lines we're trying to pass?
Yeah, wait, so is that just gonna be like a line like that then?
Yeah, because this would be the,
The y line?
no, those lines. Just any random line you would draw. Any horizontal line. There's no line. What do you, I don't understand, I guess, what you're asking.
You're asking if it passes the
Vertical line test.
vertical line.
Meaning you personally could draw any vertical line. And it would only hit the graph one time.
That's why it doesn't work, because on the other side it doesn't pass the horizontal line.
Right.
Because it,
On the other side, if we left all of it there, it wouldn't pass the horizontal line test because it would hit it twice. But if I covered up the left or I covered up the right, I'd have all the values, correct? I'd have from 0 to positive infinity. I wouldn't limit anything, would I? If I took this and deleted the left, it's not there. And I drew any horizontal line. How many times does it hit? How many times does it hit the graph? One. That means every y has only one x. Now, does that make sense? If I take it and cover up the right-hand side, does it still work? Yes. But if I leave the whole thing, it fails the horizontal line test. Because when I plug in 1, I get 1, negative 1, I get 1. And when I plug in positive 1, I get what? 1. I'm getting 2 answers for every x, and I need only 1. So if I cut this at 0 and only have from negative infinity to 0, I have all the y values, don't I? I just have them one time. If I go from 0 to positive infinity, I still keep all the y values, but how many times? Once. So then I've taken a function that wasn't one-to-one and made it what? One-to-one. So we can take functions that aren't initially one-to-one and we can restrict their domains and make them one-to-one. Now we're not going to do a whole lot of that now. We will do that in pre-calc when we do trig. We have to. And we'll talk about that more. But we have also talked about in here that domains are typically all real numbers, aren't they? Until we put them into an application problem. So that's one of the things we need to realize, that we can restrict domains. We just tell people you're only looking at this much. Okay, so to make it one-to-one, what two tests does it pass? Horizontal and vertical line test. What's the point of that? Okay, now it says find the inverse of each function by identifying appropriate restriction of the domain. I don't think you have to do that today. Let me check. Because if you don't have to do that today, I would like to say that till tomorrow.
That would be nice.
287.
That would be
You're just not going to do it then?
No, oh, might.
Oh my.
So you're doing 4 through 8, right?
yeah.
And
4
10.
through 8 and 10.
Really? That's what I said.
Hi, son. You're lucky.
I like how the video is just gonna have
Okay.
silence.
So we're not going to do this one, but I want to go back here real quick. When I say restricting, unless it is one-to-one, like I could find the inverse of this function. We just did, actually, on the slide before, didn't we say it was y equaled plus or minus the square root of x?
Yeah.
Yeah? Okay, so we can find the inverse, but is that inverse a function? No. An inverse is a function is every x has one y. And if it does not pass the one-to-one test, then its inverse is not a function. Okay? So if it's a parabola, is it going to be one-to-one?
No.
No, never. Okay? Unless we would take away part of it. Correct? Okay. So we're not going to do this one today. We are going to find the inverse of each of these functions. So, how do you find the inverse of each of these functions? Switch x and y. So do it. You have 2 problems.
It's supposed to be 3 on the second one.
Thank you. It's supposed to be 3.
Wait, that's all we do?
No, you have to solve for y.
Oh, I don't know how.
You need to try.
I did try.
You did not. You just said you didn't know how. You didn't even try. Okay, how'd you guys do on the first one?
I almost got it right.
No.
You almost got it right?
Yeah.
Okay, how do I get rid of a square root?
Square.
Square it.
Yeah.
So I square both sides, right?
Okay.
So I have x squared equals y minus 2. And then I do what? Add 2. So you have y equals x squared plus 2. And so that's your f inverse. Correct? Okay. So now how am I going to get rid of a cube root?
100 by 1/3.
It is to the 1/3 power. How did I get rid of a square root? Squared it. So how do you get rid of a cube root? You cube it. Oh, wait, can't cube it yet. We got to get rid of the what? Negative. So I have negative x. And is this what you meant to do, Cadence? Like write it like that?
Yeah.
Okay. So if you write it like that, then it might help you see what you have to do, right? So now we're going to take both of them to the what power? Cubed. So I have negative x cubed equals 4y. And then you?
Divide by 3. 4.
Thank you. Divide by 4. So y equals negative x cubed over 4. Oh, I didn't mean to do that. Oh well. Okay. Does that make sense now? Okay, so what was throwing you guys off when you were looking at those?
I think these are easy.
I think I just did it wrong at first. I just didn't do it right, but I know how to do it.
Okay. So you guys know how you should do these? We've done them enough,
it's
right?
like what we were doing.
Right. We've solved equations like this, but now we have to just remember to do what with that x and that y?
Switch it.
Switch them. Okay, find the inverse.
It's gonna solve itself. Watch.
Squint hard, it will.
But I really much love it.
Yeah.
So do you want X or Y by itself?
Why?
Y. Okay. That's
I know it's kind of hard because we're normally used to solving for x, right?
yeah.
But when we write an equation, we typically write it as y equals. So we're not solving for one of the variables, we're just writing it as something we would graph.
Oh, yeah.
How'd you guys do?
I did not get it right.
I mean,
Okay, so did you start by moving your 2 over?
yeah.
I did it eventually. Yeah, I started.
Yeah, you got to, that's the first thing you have to do.
Yeah.
Okay, and the next thing I have to do is take care of the what?
Huge.
Nope, the negative.
Ooh.
So then that's how that became negative x plus 2, right?
Alright.
Because I'd have to multiply or divide both by a negative 1. Then I cube it. And you notice I did not make you cube out the quantity, did I? That would be a key, wouldn't it? Now, if it's squared, I would expect you to square it out, but not cube. And then you subtract it over the 1. Good? Bad?
I see what I did wrong.
You see what you did wrong?
I just
Yeah,
cubed
because-
the
I just
2.
didn't
That's why I
give
was.
mine to positive.
Yeah, and I just.
You
kinda-
changed your x, but not your 2.
I had the negative just disappear over time.
Oh,
instead of
okay.
doing anything with
Okay.
it.
When that negative comes over, you're multiplying the quantity by a negative 2. I guess you could have left the negative out in front. I mean, a negative, you could have left it out there. Now, when you're cubing, that means we're doing negative x plus 2 times negative x plus 2 times negative x plus 2. Remember? So I'm not going to make you do that, so don't be cubing that 2. It's naughty. Questions? Concerns? And then I would just write that as f inverse, right? Now, can I write it 2 minus x cubed? Can I write it like that? Yeah. And I probably would because it looks better to me. Okay, so now how can we tell if things are inverses of each other? Well, there's a very specific way. We have to take, in order to tell whether something is an inverse or something, you take f composed of f inverse. Remember we did g of f, right? The last 2 days. So we would take f of f inverse, and it has to equal what? X. And you have to take f inverse of f, and it has to equal what? X. Because you saw the other day, we did f of g and g of f, and did we get the same answer? No. If you get the same answer, guys, they're inverses of each other. So that's what we have to do to verify it. Okay? So when I say verify they are inverses, you have to do f inverse and f inverse x. The composition of functions, right? That's what we've been doing. You have to do both. So find the inverse of the function, and then I have to verify that we're right. So I have to do what first? Oh, we did this already. Did we do this one already? Wasn't that the one on the last page?
Yeah.
Yeah? So what was f inverse? What was it? Wasn't it 2 minus x cubed minus 1? Okay, so we already found f inverse, right? Now we have to verify it. So we need to do f of f inverse of x. So we're going to put f inverse, this whole thing in, for that x, right? Okay, so we have 2 minus the cube root of x. What's x now?
2 minus x to
2 minus x to
the third minus 1.
the third minus 1. And then we have to do what? Plus 1.
I cancel each other.
So the positive, negative 1 are 0. Yes? Well, if I take the cube root of something cubed, don't I just get what's inside?
Yep.
Yep. So I now have 2 minus
2 minus x.
Parentheses.
2 minus x. So I have to do what with my negative?
Get rid of it. Just repeat.
Distribute it. So I have 2 minus 2 plus x gives me just what?
X.
X. Is that what it was supposed to get me?
Yes.
Okay. So now I have to do F inverse of F. Now, it sounds really bad, but did that just kind of fall away? Like everything just kind of melted away, didn't it? If I do it right, it should. It should just be kind of melting away. So now I got to take this whole thing and put it in for what? That X right there. So I get 2, parenthesis, right? 2 minus 2 minus the cube root of X plus 1 cubed minus 1. Okay. So 2 minus 2 is 0. Oops. That's 0, right? So I need to take this cube and I need to cube negative 1 because there's a negative 1 there, right? And I still get a what? Negative 1. So negative. And then I cube the cube root and I get what?
X plus 1.
I get parenthesis X plus 1. Something's wrong. Okay, then what?
And then you distribute the negative.
What's wrong?
It equals X minus 3.
Yeah, you did it wrong.
We did something wrong, didn't we?
Or the problem is just not right.
Well, if we didn't find the inverse correctly, then it's going to be wrong already, right? So let's see if we found the inverse correctly. We have the inverse of the cube root, or 2 minus, yes, that's right. Okay. So we found it right. So we did something wrong when we simplified, didn't we? So let's look at this again. Let's plug it back in, because we better get X, because we got the right inverse, right? I want to know what I did wrong. I shouldn't have erased it, because then if I erase it, then we'll do it right, and we won't know what we did wrong, huh? Okay, so we're putting this whole thing in for that X, correct?
Yes.
Okay. Oh, I know what we did. Okay. So 2 minus parenthesis. Guess what we forgot?
Why do you need another parenthesis?
We forgot the parenthesis. When we're going to plug all this in, don't we need to put a parenthesis there?
Why?
Because what do we have to do with this negative out here? Distribute it. And what didn't we do last time? Distribute it. So are parentheses important?
Yeah.
Yes. Okay, so we have 2 minus X. The whole thing is cubed, yes?
Don't you need your negative 1 too?
Yeah, I just hadn't done it yet.
Oh,
Okay. So now what do I do with this negative?
Distribute.
Distribute it. So makes this a negative 2 and a positive there.
Yeah.
So now 2 and negative 2 is what? 0. When I cube the cube root, I get what's inside. So I get X plus 1 minus 1, and I get what? X. So if you don't put your parentheses in, are you going to get a right answer? No. I forgot my parenthesis. So we found the inverse, and we verified it was correct. Can I only do one of these and have it verified? You have to do what? Both. Make sense? I think we need to do it again. What do you think? Okay. Are these inverses of each other? If they're inverses of each other, we're going to get F. Ugh. We're going to get F of G of X, and it's going to equal what?
X.
X. And we're going to do G of F of X, and it's going to equal what?
X.
X. So, I said G and wrote F. Equals what?
Square root of X minus 5 squared plus 5.
Okay, square root of X minus 5, quantity squared
Plus 5.
plus 5.
minus 25.
Okay, so I've got to square this quantity, correct?
X minus 25.
No. Because to square that quantity, don't I have to FOIL it? So I get x minus 5 square root of x minus 5 square root of x plus 25 and then plus 5. Is that going to give me x? No, that is not. That's going to give me x minus 10 square root of x plus 30. Do I even need to do g of x? No. So this is a no. Now, should you go back and verify that you did it correctly? Yeah. But it says x squared, doesn't it? And this is the whole quantity. And if I square that quantity, I have to FOIL it out, don't I? So it's a no. If the first one works, do you have to do the second one? Yes. Riley, stay awake. Okay. So are these two inverses? So f of g of x. So it's 1/4 of x, but what's x?
4x minus 7.
So 4x minus 7 plus 7.
Oh. So it's x minus 7/4 plus 7. Sure. Yay.
Okay, so this would be x minus 7/4 plus 7. Is that a yes?
No.
No. Because if this was 7/4, would it be a yes?
Yes.
But it is not, is it?
No.
So I wanted to show you some examples of no. If it is a yes, it just kind of melt apart.
Yes.
Yes. Today, your assignment, guys, 4 through 8, is just stepping you through, like, it says, like, find the inverse, verify their inverses. Does that make sense? It's not going to ask you to do a whole lot. And 10 is a find the mistake. Tomorrow, we'll do more problems actually doing all of this stuff. Got it?
I'll use
So there shouldn't be a video tomorrow.